we have the graph of g of x, and we want to sketch the graph of y equals negative g of x. So first thing we have to figure out is what kind of reflection is this? Are we reflecting over the x-axis or are we reflecting over the y-axis? Well, that negative is outside of the function. So it's going to be reflecting things vertically. If you think vertically, up and down, that's going to go over the x-axis. So we can take some key points. I would say this looks like a key point and this looks like a key point that are on our graph, and we can flip them over the x-axis. So when I find my new points, well, this one is 6 away, so it's going to be 6 down. This one's 2 away, it's going to be 2 down. Those are going to be our two graphs. Where are my blue and red graphs? When I draw my blue graph now, there's going to be one point where both of them intersect. There's going to be one point that doesn't change. Where is that point? Why doesn't it change? 0. So what do you mean by 0? So I'm coming like this. It looks like right here, right? Why does that point not change? At the x-intercept, or at the 0 of the graph, they're going to be the same. Why is that? So because it's right on the x-axis and we're flipping over the x-axis, does that make sense that that would be one reason why it doesn't change? So that's thinking about it graphically. If we think about it as an actual point, when we reflect over the x-axis, what are we doing to the points? Like, for example, this point here is 3, 2, and then this point here is 3, negative 2. What are we doing? We're multiplying our y values by a negative 1. So when we think about this point over here and say it's something, I don't know what the x-coordinate is, it's something, 0. And when I multiply the y by a negative 1, it's still going to be something, 0. So that's sort of an algebraic way of thinking about why it doesn't change. One of the things we want to do throughout this course is we want to be able to think graphically, algebraically, have as many different representations to understand a problem that we can. So here we can see that that point doesn't change, because if it's on the x-axis and you flip something over the x-axis, it's going to stay the same. Algebraically, what's happening when you flip something over the x-axis? You're multiplying y by negative 1, so it's not going to change. This one for the red graph and the blue graph for our domain and range. Well, our domain was everything, our range was everything, and for our blue graph, the domain and range is everything again. So in this case, nothing changed when we did the transformation. Okay, questions we can practice. 4, 5, 6. (10 and 11).